Okay, so we are going to practice going from moles of one compound to moles of another. Anytime that you have two separate compounds in the same question, you need a balanced chemical equation. So if you're not given a balanced chemical equation, the first step, anytime that you're dealing with two different compounds in the same question, you need to balance that chemical equation first. Okay, let's go ahead and read our question. It says, how many moles? Okay, well, how many means X. Then I have moles. So how many moles of NaCl? So that means I'm looking for moles of sodium chloride. And it says are required to produce. That's going to be my, hey, these numbers are related. And then it says 18 moles of Cl2. So then I'm just going to put the given number from the problem into my setup. 18 moles Cl2, which is just atmospheric chlorine. Chlorine by itself is diatomic, so we're just going to refer to it as chlorine. Okay, so I have my English version of the question translated into math. Now, what I need to do is I need to figure out how in the world I'm going to get from moles of chlorine to moles of NaCl2. Sorry, just NaCl. Don't do NaCl2. There is a relationship, and that relationship was given by our example equation here. I'm going to go ahead and I'm going to underline the two compounds of question. I have NaCl, and then I have Cl2. Those two are the ones that I actually care about, so I'm going to just go ahead and visually connect them, and that way I don't end up looking at anybody else's ratios. Remember that a balanced chemical equation is going to be a recipe of sorts. For every this many of this, I get this many of that, all that kind of stuff. So I'm going to go ahead and I'm going to turn these into ratios. I see that there's a 2 in front of NaCl, so I'm going to put a 2 here. Then we're dealing on the scale of moles, so I need to go ahead and say 2 moles. And then the compound formula. So for every 2 moles of sodium chloride, there's no coefficient here, so it's an invisible 1. For every 2 moles of sodium chloride, I have 1 moles of chlorine. Okay, so that's one way that I could write the multiple ratio, and I'm just going to do it the other way. I can also, not changing any information, say for every 1 mole of chlorine, I have 2 moles of sodium chloride. Okay, so I have my molar ratio now. Now I'm going to actually look at my setup to see which version I'm going to use. Remember, we're trying to cancel out moles of chlorine, so I need the version that has moles of chlorine on the bottom. I see that moles of chlorine is on the bottom for that very first one, so I'm just going to go ahead and box it and say that's the one that I'm using. And then I'm going to go ahead and plug it into the actual train track setup. So I will put 2 moles of sodium chloride at the top and 1 mole of chlorine at the bottom. Okay, now I see that I have moles chlorine, which means that I can cancel moles chlorine, leaving me with the only English in my math being moles NaCl, which is the thing that I said that I wanted, so I'm good to go. Now all I need to do is actually plug it into the calculator. Remember, we multiply everything that's on top, so since 18 and 2 are on top, we multiply those together, and we divide by everything that's on the bottom. Only the number 1 is on the bottom, so we're going to go ahead and say 18 times 2 divided by 1. Okay, that gives us the number 36. That's already a whole number, so I'm just going to not bother to round that number, and we're going to be using the unit that we have left, the unit that we said that we wanted, so 36 moles of sodium chloride. I'll just go ahead and box that answer as that is my final answer. Okay, let's try another one. So here you see that I already again have a balanced chemical equation, and I see that the two substances that are in here are going to be potassium sulfate and aluminum sulfate. So I'm just going to go ahead and I'm going to underline those, letting myself know that, hey, those are the ones that I care about. And I'm going to go ahead and visually connect them. And let's just go ahead and do that multimole ratio now while we're dealing with this. So I see that I have 3 moles of potassium sulfate for every 1 mole of aluminum sulfate, or for every 1 mole of aluminum sulfate, I have 3 moles of potassium sulfate. Okay, let's go back and go ahead and translate this problem into math. How many moles means X moles. Potassium sulfate is the compound that is attached there, so I'll go ahead and attach it here. How many moles of potassium sulfate are needed to produce, these numbers are related words, 9 moles aluminum sulfate. Okay, so we've translated it into math, and we already did that work of putting these multiple ratios into usable forms. Now we just need to figure out which one we're going to use. I see that moles of aluminum sulfate is on the top right now, so I'm going to pick the one that's on the bottom. It looks like we ended up also using that top one again, so that's nice. And we're going to go ahead and we're going to plug that in. So for 3 moles of potassium sulfate, I have 1 mole of aluminum sulfate. Moles aluminum sulfate leaves me with moles potassium sulfate, which is the thing that I said that I wanted. So I can go ahead and plug everything into the calculator. It looks like I will be multiplying 9 and 3, since they're both on the top, and dividing by 1 because it's on the bottom. So let's go ahead and multiply 9 and 3 and divide by 1. That gives us the number 27. That is, again, a nice round number, so I don't feel the need to round here. And I'm just going to go ahead and attach the unit moles potassium sulfate. Let's do one more for good measure. Here we have a combustion problem, and it says how many moles of O2 are required to completely react with 3.6 moles CH4. So these are the two compounds that I care about. Let's go ahead and visually connect them and make our multimole ratios. So for every 1 mole of CH4, I have 2 moles of O2, or for every 2 moles of O2, I have 1 mole of CH4. Let's go ahead and translate this problem into math. How many question word turns into X? Moles, compound connected to the word moles. How many moles of O2? X moles O2. Set it equal for the are required to completely react. It's a whole lot of words for just one little symbol. Number given in the problem, 3.6 mole CH4. We're setting up the train tracks. Okay, so we need to cancel out moles of CH4, so we're gonna go ahead and pick the option that has CH4 on the bottom. It looks like that's our second version this time. So I'm going to go ahead and box it as that's the one that I'm going to use. And then I'm going to go ahead and plug it in. I'm going to have 2 moles of O2 on top and 1 mole CH4 on the bottom. Now you might have noticed that everything so far has just had 1 on the bottom. That's just a coincidence for the problems that I picked. Do not just automatically assume that whichever one has 1 on the bottom will be the one that we're dealing with. Always look at that unit. Okay, so moles CH4 both cancel, leaving me with moles of O2, which was the unit that I said that I wanted. So I can go ahead and write myself out what math I'm gonna do. 3.6 and 2 are on the top, so they're going to multiply, and 1 is on the bottom, so it's going to divide. Let's see what 3.6 times 2 is. That gives us the number 7.2, which is also a nice number, so I'm not going to round that number, and I'm just going to go ahead and use the unit that I said that I was going to find, the unit that's only one left, and box my final answer.